Okay. Well, let's start. I'm Xu I'm from eBay platform, and I will share my experience at how to develop the operator framework to manage stateful workloads in eBay. Actually, this speech was responsible for my colleague, another architect. Well, unfortunately, he's now on another business trip, so I will just perform this talk myself. For my introduction, we'll cover the following aspects. First is about the difficulties in our work and why we want to develop such kind of product. That is a background. And I want to introduce the ideas, the philosophies and functions of our kind of system. As you all know, that the eBay is a cross-boundary e-commerce company, and has business in about 196 countries, and most of the business is not in the US. And for now, the data has excesses or over 100 TB for our data platform, and we want to manage and collect this kind of data to offer services to other departments. Besides data acquisition, we offer data analysis tools, for example, the MyCircle, Mongo, and a kind of and other tools for offline services, and for Kafka, another system that developed at eBay to deal with the real-time services. And for now, we'll just manage this kind of tools and offer services for other departments. In recent years, we just follow the development trends and we migrate our work from the physical container to VM to cloud, and for now, we want to migrate our business to Kubernetes. During the data migration, we found most data are stateful, so the management of this kind of data is quite more complicated than data without such kind of status. Well, for example, this is a Kafka system. If you know of that, you must be aware that it has a quite high requirement on I/O, and we have tested internal EB for Sender, Save, Swift, and other services that are operated internal eBay, and they cannot meet the performance of Kafka. So what should we do? Thanks to our Kubernetes team in eBay, 2 years before, we have just developed such kind of solutions to offer services, that is to build a model of the workload on physical disk to workload, that is to say, when the services want to read services, they just read this information on previously physical servers. And so in this way, for Kafka system, we only need to purchase the suitable machines and to achieve better performance. While in some scenarios, this is not quite enough. For example, when disk meet issues of breakdown or failure, then the information will go back to the failure point or nodes. In this kind of scenario, Kubernetes, the original functions of Kubernetes cannot address that. Well, for another issue that we met, this is the architecture of Kafka. And this kind of deployment can increase the reliability, and we found that in each level, the local server can read the local information, and the local Kafka server can collect all kinds of data on this kind of services. So in this complicated system, it has many components, and if you have such kind of experience, if making any minor changes to a component, then it will cause changes to other components. For example, if we want to increase the node from 3 to 5 at a basic Kafka architecture, then if the VK was before the version 3.0 or version 4.2, you need to reboot them first. As for the reboot, you need to consider the order. And once the leaky is rebooted, you need to consider how the Kafka can meet the configuration. So you have to reboot the Kafka system. If you do the Kafka reboot, you want to consider how to restore, how to store this kind of data in case of data losses. But for this kind of issues, the original or native Kafka cannot meet such kind of demands. I'm not sure if you know the Galera, the system, and it's an active to active system. For now, you have to deploy at least 3 nodes for this kind of. When we establish the Gala cluster, it's quite complicated. You have to first extract a cluster and then to configure to the other 2 nodes to the cluster mode. And when they set, you have to change the first node back to cluster node. And for this kind of operation, the native Kubernetes cannot meet that. So all these examples just want to demonstrate that in the data platform, when we migrate the platform to Kubernetes, each kind of application has unique difficult logic, operation logic that need to be handled respectively. And so what kind of issues we need to solve when we migrate them to the Kubernetes platform? So the first is about the cluster management and, and how to manage the relationship and how to deal with the complicated data operation so that we can simplify the management. Well, for the second part is about the data application in the growth environment. We want to assure the reliability and high reliability. And for the third part, security is a must. We want to ensure the enterprise security policies, and we explore the existing solutions. For the first, we thought of Stateful set, and it's quite a way addresses some requirements in the stateful set. For example, we allocate the unique ID or PVC or access address, but this is not enough. As I mentioned, all these kind of requirements need to be deployed across clusters and to auto recover when the failure is not, and to reorder or automatically reorder the sequence. This cannot be met by Stateful. And for the industry, we have another solution which is quite similar to Linux system, the package management, and we can specify the establishment order and the configuration and the versions through DM file. But for some changes or automatic changes of related configurations or customize the multi-core image or customize the service logic or to connect or integrate with existing eBay system. And when we talk of these issues, we found that kind of solutions lacks of flexibility. And we have another solution that is called Operator. We found this quite suitable. Or the design philosophy in that is to transfer the experience of managing a kind of cluster to a operator, while the design philosophy is quite consistent with the management system of eBay. As operator will just analyze, observe this kind of status and find the gap between the actual and the expected status, and then we can come up with solutions. But for customers expected status, we can define the custom expected refers. Well, for the observation, the operator can use a watch mechanism of Kubernetes. Well, for the most complicated part, that is to take action. Actually, we do not have a unified standard, so we have our own thoughts, and we introduce a workflow. And we believe all these kind of actions consists of complicated ops, and so we believe the workflow is quite suitable to describe such kind of actions. As I mentioned above, eBay want to migrate many applications to Kubernetes. If we develop an independent operator for each service or each application, uh, it will be a large amount of workload. So you want to have a one-stop operator framework. It can be described as a market, and it have three kind of roles. For one is a seller, that is the data platform department and the teams of this department in eBay. And for markets, they have many new sellers. So for eBay, we can have many teams to join in this framework to management this data, and we call this data management provider. Well, for the second role is a customer in the market. Well, in eBay scenario, it is real end users. When this user joins the framework, they can choose existing functions and make combination of them freely. They can choose the single Kafka cluster or Kafka plus Doof or other services. While for the third role is about the owner of the market, that is to say, the developer of such framework. That their responsibility is to find the similarities of this kind of works, and thus they can offer services to operators so that they can easily to develop and management their services. And with such kind of market, and we can see what kind of functions does it have. So we can first apply for a cluster. When we do such kind of applications, we can check the status of customer's client. With custom resources, we have the standard custom interaction interface. And just as used on the Kubernetes API, customers can describe expected services, expected versions, configurations, and the number of nodes, or they can combine several services. And in this example, they choose a ZK and the Kafka cluster. And secondly, with expected uh, status, how to transfer them to physical Kubernetes resources, how to transfer them to PVC. Due to each kind of data has different requirements. Some have high requirements on performance, so I will recommend the local PV for the local PV mode for this kind of data so that they can ensure a higher performance. While for other like Flink and Bug and data, they may want to simply use the deployment services. While for other kinds, you can freely combine this kind of services to meet your customized demand. Well, when the newcomer want to join our framework, and they can decide what they can decide their service type. They can define them themselves according to their need. Well, as I mentioned, some functions or services need to be deployed across this kind of cluster. So how we can make that possible? As you can show it on this slide. And once the user submit a request, this request will be transferred to a controller, and then the master will decide, and the scheduler will allocate the resources and take actions. Well, the difference is that each Kubernetes cluster will deploy a watcher. The watcher needs to monitor all the health status and changes of the resources in all Kubernetes cluster. It needs to also connect the information. So only the controller only need to know the status of the water, and then it can make decisions what kind of resources you need to integrate it on the server. Of our other features, I listed some general ones, for example, the deletion, auto refill, auto scaling, reboot, update, configuration, replacement, the failure, the points, and etc., which are quite general or common features required. And we also offer such kind of services. Well, due to each functions when they perform that, they are not quite the same when dealing with this kind of issues.
So how do we solve the problem? It's the workflow we have talked about. Why do we want to do workflow? Just think about a few scenarios. If I want to create a pod, but the internet is not good, or there's a problem with the API server, I need to recheck frequently. Or if I need to do a more dangerous operation, I need my I need my boss to approve me, and I need a cluster, but the controller is down. So how would I know where am I? Do I have to redo it? For each application, the scenarios needs to be considered and needs to develop certain logic to process it. But if you have a framework that covers all the scenarios, so the service provider only needs to focus on their own logic of the applications, then it will become a lot easier. So for DevOps, common scenarios, we developed our own workflow engine. So we process and treat these problems at engine level, like approval or rolling upgrade or the gray release, etc. With this mechanism, we there's another benefit to us. It makes it a lot flexible and easier for us to abstract all the common logic. So this is the second function we are able to offer. In the framework, we are able to provide a lot of common tasks and common workflow for cluster management. There's an example here. It's a Kafka and Mongo build. You've got to establish a lot of Kubernetes resource, but for Kafka, it can automatically transfer to cluster. For Mongo, you've got to go through a lot of complex operation like replica set, or you need to establish the system users, etc., etc. So for framework, we only need to provide a common Kubernetes resource and just need to test if there's a common flow that's created. And for the Mongo, on top of the common flow, you just need to add up your custom logic. Another case is the configuration management, or the application needs this, so provide a mechanism on framework level. We have done version control for the configuration, so the users can define different versions of config, and they can also pick a certain version of configuration. We will read the content of the configuration and establish a config map and put that into all the pods. When you need to modify this configuration, you just need to modify the version. We just will read the new configuration and refresh the config map. All the binded files will be automatically updated within certain time frame. If you can dynamically add the new applications, then they can be managed dynamically. If not, you've got to custom your dynamic flow. So on top of those operation, you just need to add some logic to test if the logic is updated, and just need to add the rolling reset flow. It's a bit like building blocks. At the framework level, we provide a lot of blocks for you. All you need to do is to build them up. If you don't feel there's enough blocks for you, you can also customize those blocks, so that there's the lifecycle management. Then what functions we provide to increase the reliability? First of all, we have our self-check mechanism in the system. So for all the applications in the framework, including the framework itself, we provide a health check function. There will be a regular execution for the health check flow. For some basic checks, they will check if the resources on Kubernetes is healthy or not. It will check whether the service is started normally, whether the interface is connected. You can also customize this checking mechanism by yourself. When there is normally, we will send the alarm to your email or Slack. And for some common scenarios, we have auto recovery. For example, if your pod is deleted or your PVC is deleted, then it will be integrated with the recovery flow, so it will be automatically fixed. In addition to the self-check, we also add our own set card agent. It has an external server and UI in itself. First of all, it can proxy some useful operations as a RESTful API. It can execute some orders or ZK Kafka application level orders. Of course, there is control, and not everyone can execute this applications on these operations. There's a UI, so it makes it a lot easier for you to check the log of the application. So it makes it easy for you to debug, and also it integrates all the metrics at the system level or application level, and with a third-party systems like Prometheus, it can integrate with it. It can also custom some logics to check your applications whether they are normal or not, and these metrics can also be integrated um, and integrate with the third-party monitoring system. Thirdly, because our agent is deployed on the same pod in a server card, it can share the same system file with the major procedure, where it can also automatically check if the disk is good or not. We talked about how it automatically recover if a disk fails. So when there is a disk failure, the event can be sent to server end, and it can integrate with the auto recovery flow at the server end. So for this broken disk and broken part, they can be deleted. It can be rescheduled to a new and good machine and migrate all the data to the good machine. And for certain applications, some applications has secret information in it. For example, the database have their own password. You've got to regularly update it. So we have a function it will monitor the secret files in Kubernetes by our custom specs. When it checks some changes, it can automatically update the password of the database. And in the end, uh, we also improve the security of the applications. Of course, we think about the authentication. It is integrated with a keystone, and for us, the users provide resources to us. They provide us their namespace. So the users can decide the namespace is open to whom, they grant the permission to whom, and we only allow authorized users to operate in their own namespace. They are only allowed to operate the applications whose authorization is opened, and also we'll make sure all the applications from our framework are start from the root users, and it'll start use this SASL encryption. We provide standardized process to make sure that the users don't have as much risk in production. For example, we will limit the users' authorization when they finish certain operations, they will be granted a higher level authentication, and they can do only certain operation when they get the permission. And we also did some integration to make sure some dangerous operations will not be executed in some risky time frame. So we actually used the design concept of operator and developed our own system to make it easy for the data application providers to manage their framework. Comparing our own solution and Kubernetes' own state set and design concept, we provide more flexibility because in any lifecycle management, the users can customize their own logic. So instead of Kubernetes, they can only do something before or after the pod is created. So comparing with the Kubernetes design concept, we actually add a higher level abstraction. We provide a workflow interface to make it easy for the users to define their own logics. We think the solution is good for eBay when we need to manage and when there's a stateful, when we have a stateful application, it will be very suitable. So we'd like to share this suitable application and suitable solution to people who might be able to use it as well. Thank you very much. Do you have any questions?
对，
For this operator concept, it's promoted by CoreOs 2 years ago. It only managed the complex application with state. Every application has its own operator, is best, but there are a lot of applications. But if you do an operator for each application, you might not have enough resource or power. If you put the same logics together, there might be a lot of logics because each application has different logics, like a Prometheus or etcd. They have very different logics. How do you manage that in this case? And afterwards, who is going to maintain the common logic? And for this common logic you're talking about, who is managing the operator itself?
这个就是我刚刚前面提到的，
I have mentioned we have 3 roles.
通用的部分就
For
是
the common
网
one,
络部的开发者，
it is by the framework developer, us, but the volume will grow bigger and bigger. The size will be bigger, bigger and bigger.
因为
Yes,
我们用了 workflow 的这个
because
概念，
we adopt a
可以
workflow
像这样举
concept,
个例子，
as
其
you
实
can
它
see from
是
this example
每一个
here.
应用都会有自己的
Each
一个
application will has its own workflow.
因为
Yeah,
这个我觉得
okay.
是很容易的
Because
拆分的，
this is a
并且因为
logic
这
that's
个每
easily
个
broken
步骤
down, and
它就
for
是一个
every
普通的
step,
task
for
这样一个
example,
概念，
a
然
task
后一个
is a
workflow 可
section
能
of
会是一
code,
个 YAML
and
的
for a
文件，
workflow, it is a
那你
YAML
你做的事情就是
file.
你每一个应用自己
What
都
you
会自己的
do
一套 workflow，
is you
然
have your
后
own workflow for every file,
对，然后你可以
and
从通用的那些 task，
you
通用的
can
flow 里去拿到一些
take
你想要的东西，
the
然后
things you
不断
want
的
from the
去
common workflow and common work task to build your own flow. So as a user, I can customize my own workflow and
对对
pick those from the
你
common
你不
workflow.
是终端用
Yes,
户，你
because
是
you are not the end
比如
user.
说 Kafka 这
For
样一
example,
个
you are
平台，
the
或者是
Kafka
是一
provider
堆这种
or
东西，
etcd
你会
provider.
发现，
You
我
will
都在上
realize
这样
that
这一堆的
you've
资
got
源，
to
那这个上面
establish
资源的
or
过程，
create
现在很
all
多
these
是已经有
resources,
的，
but
那我就是让它
the
多用
resource creation process is available in the framework. You just need to take it and use it. I understand then. For etcd itself, there's also etcd operator, right? Yeah, I know that. That's why I compared them just now. I compared the
其实
differences
是因为 operator
because
etcd
for
operator 里面的
etcd
运用是有
operator,
很多的
they didn't
东西的，
say how to
这个
write
东
their
西
controllers.
就当然你去看它的代码
Of
是怎
course,
么样
if
的，
you check the
但是它
code,
里
you
面
know
给
how
所
it's
有的
written,
operator 会给
but
你
it didn't
特别
say
的
that when all
给
the
你特别
operator
的
write the
这个
controllers, how they need to process the logic in the controllers. Well, you don't have to see
对
that.
对对，
You
你
just
说的
need
是终
to
端用
use
户，
the
我说
service.
的是
But you're
谁来
talking
写这个
about the
etcd 的
end
operator。
users, but I'm talking
因为
about who's going
因
to
为有
write
新
the
的应
etcd
用，它里面
operator.
有 operator， 像
There,
Kafka 现在没
there's
有
got to be
Kafka
someone to
相关的
write
operator， 它
it.
里
For
面有
example,
Python，
if there's
我们
no
是需要
operator for
写
the
这个
production, there will be
operator，
someone to
然后
write
给
it
它
up.
看的好。
I'm just trying to reduce the effort for those who are going to write the operator. But Kubernetes actually
我们也
develop
说
a
过，
operator
其实刚
SDK.
刚也确实有
Yes,
我们
I also
和
compared that
CoreOs 的那
with
个
the Core OS.
workflow
We
的区别，
compared the
因为
differences
它
of the
的如果我
Core
刚提到的那个
OS
SDK， 但
framework.
是它
Even though
还
they
是没有
provide
说
SDK, they
我
still
每一个
didn't
应
talk
用自己
about
的那个 controller 都是要怎么
the
写。
logic of each
那我们其实就是把
application controller.
controller 这一块里
So
面
for
给所有
us,
application 可以重用的部分提取出来，
we
说你沿
extract
用上面就可以
the
了。
reusable logics from the controllers. So for eBay, I just need to use
在
what you have
eBay 上也
said.
是这样的。
Yes, that's the case. Inside eBay, we didn't open source it. Not open source? No. Okay, thank you.
你先吧。
So here, this gentleman, sorry. Two questions. So I'm also working in a data team to provide service in such a platform. I see you extract a lot of infrastructure logic in the framework. But in the framework, I didn't see the management of data. For a data team, data is quite important to them. So it's quite troublesome to manage the data, for example, managing their own data or external data or labeled data. So do you have an experience in this regard?
Do you have extract that to the framework? No, we haven't do that or haven't done that since each type of data actually has different requirements of data processing. Actually, we are developing all distributed data models. Well, for outline this, we use the Mongo as a storage engine,
做 operation 的时候，我们后
and
续
with
可以
that,
用
when we
这
do
个
the
芒果
operation,
的数据去做从一台机器到另一
we'll
台机器。
transfer
就是它
or
按照它
migrate the
的
data
作用
from one of
建
the
立
Mongo
一个
machine to
对
the other.
没
Well,
有
for the
办法
Kafka
去
system, it's
做
not quite
这个。
possible.
所以这
So
块我
we
们
call the
并没有
data is
没
quite
有
a
把
flow.
这个
So we
去
cannot
交
do
给
that,
每一个应用
but we
服
just
务器
transfer
去处理。
work to
第
the
二个问题
provider
就
of each
是
task.
我们
Well,
的
for the
处理实
second
现了类似
question,
的这样一个风
well,
暴
for the
体这样
loop
的
is
一个流程。
actually
当
we
我们
achieve
就是
such
去
kind
实
of
现这个的时
mechanism,
候，发现
but
其实
we
我们
achieve that from
一
two
一
paths
条呢是做 command
available.
模板，
But first,
另外
that
一
we
条
use
呢
this
就是做的是数据库体
existing
系的。
template. The
当我们看
second
到就是
to
像现在
incorporate
你
with
的平台
existing
化是一个
database.
command
But
的一个
for
模
your
板，
current
和他们这几个
path,
同步，
you
那我
just
们
do
在相
the
对应的收
template
入。
and the
那么
operator
为
will
什么
do
要走这个
self-maintenance
路
and
呢？
you do the
你所谓的这个数据
visualization.
库的
But
理
why
解是
not
说
choose
你
the
自定
database
好
path?
一些设
For
定
your
周
path,
期，
well,
然后
to
在
my
某些
understanding,
阶
either
段
you
让用户可以
customize
发
the
挥这个
life
我们的
path,
审计用
and
数
in
据
some
库是
certain
用一
stages,
套
the
核
user
心
can
的
just
体系。
plug into
那
access.
其实跟我们这个我觉得应该是类似的，因为
Well,
我们的做
actually,
其
it's
实它
quite
也是一个
similar
graph，
to our
你决
workflow.
定
Well,
每一
our
个做什么事
workflow
情，
is
只
similar
是
to the
具体的
graph,
实施
and
是
at
不一样。
each
你可以
stages,
这么
the
说，
customers
说
should
说的话呢，更
decide
多是采
to
用
do the
BAT 的结
things,
构
but it's in
对吧？
different methods.
我们其实是一个 graph，
这是
We
一个。
actually use a graph.
我们不是单向的，我们
OK，
是有
那这个
We're
那
not
么
the
这样
single
一个
direction.
workflow 对吧？它放到数据
Or
库里
for
面，
your
它直接是个
workflow,
外码
once you just
给
put that
进行
into
做
the
编辑。
database, how do you manage that? Well, for the workflow YAML, it is a YAML template, YAML file template. Or for the other, it's like the Java logic.
这个 framework 有没有名字？
Well, do you have a name for this framework?
有。
哦，
Yes, we
可以
have.
告诉我吗？
Can you tell me
我
that?
目前没有开源，但是
Well,
因
no,
为
we
我
do
们
not
知道
do the open source one internally. We call that
那
NAP.
NAP 会不会还是现在有没有一个 workflow 可以
Is
帮
there
我，
an
比方
existing
说
workflow
在
for the NAP to
RDBMS
help me to do
relational
the
database
relational
甚至一个
database
Sprout，
parse
然
or
后
even
可
the
以
Broad
文部署还是这种类似的一个 workflow。
to push that? Do we have
I,
such kind
let me
of
let me
similar
give another
workflow?
example. Schema change.
我会
If
举
I
另外
want
一
to
个
roll
例
out
子，
a
比
schema
如说
change， 然后 schema 坏了，
schema
我
change
可以
呢，如果
回到以前的
一个
那个状态，
这个
它
schema
可以
change
负责
已经坏
这一块儿吗？
掉了。What if we how can we change to the change back to the status?
只是
Well, we
目
have
前我
such
们还没
functions
开
to
源，所以你如果有兴
this
趣，我
kind
们
of
可以再谈。
database, but we cannot have
有
open source
兴
that.
趣。
If you're interested, we can offline
时
discussion
间问题我们
because
分
I'm
给我们。
interested in that. It's a limited, only one last question. Can we turn back to the Cube controller? How do you manage that? Since we have the workflow cluster, and how can the controller do that? Well, for the controller, it's actually a code. I know that it is a code. But how can it incorporate with a Kubernetes? It uses a Kubernetes customer resource. It allows users to describe such functions in the method of the Kubernetes API, and the Kubernetes only need to make the work done. But how can you do the multi-cluster? Well, we have the voucher. In each Kubernetes cluster, we'll deploy each voucher and we'll monitor such kind of changes. And the proxy local KubeCon. I mean the communication for the controller and the Kubernetes. Do you use the standard? Well, for the communication between server and the controller, it uses IPS protocol. But for your controller, did you realize the logic? Well, for our communication method, the users customers watch your mechanism, and we watch the mechanism. Once we detect such changes, and we'll tell the server, and the server make the whole work done. A server, so that is a control API. Well, I have to say, I have to conclude my speech. If you are interested, you are welcome to the offline discussion. Thank you.